Okay. And so again, the reason, yes, we know that, is given information. Okay, again, guys, this is not like an arbitrary thing I'm asking you to do here. The piece of information that we're given, this congruence, okay, the statement, we're stating this thing is congruent, and the reason we know that's true is because it was given to us. All right, I'm going to go over here and mark that as well. So since it's my first pair of congruent sides that we're talking about, I'll go ahead and mark that with a single tick mark. Okay. Now we have one other piece of given information here, which is Rn, okay, is congruent to Tu. Okay. Now when I go to mark that over here, I'm not going to use the single tick mark. I already used the single tick mark for this pair, so I'm going to use the double tick mark here. Okay. I walked around and saw some people, they use the double tick mark here and a double tick mark here. You don't want to use the same congruency mark unless you know that all four pieces are going to be equal. Since we don't know that, we only know that these two are equal and these two are equal, we have to separate them, so different tick marks for the different pairs. Different tick marks for different pairs. Okay, again, that was given to us. Okay. All right. And then let's see here. Let's go to Gabe. What's our final congruence we want to list here? What's another congruent piece?
Is it RT?
Yes. RT is congruent to RT. Okay. And what's the reason here? Is it given to us?
Yeah. Well, they share the same line.
Okay, it's shared, so something congruent to itself, what's the property we use to say that something is congruent to itself? We have a property, that reflexive property. Reflexive property. Remember, that's what we've talked about before, reflexive property. Okay, and I know it seems so obvious, it's like, why do we even need to say, why do we even need a reason for that? Of course something is equal to itself, or congruent to itself. Okay? So, step 4, last step, we have to now name the two triangles congruent, right? We have 1, 2, 3. In fact, you can even go up to, okay, these are sides, so we have 3 sides there, okay? So let's go to Josh. So Josh, how can we name these two triangles? Oh, he's not here, there. He went to the office. All right, let's go to Eric. How can we name these two triangles congruent?
Triangle RUT.
RUT. What?
Triangle TNR.
TNR. And folks, if you don't like, if it's tricky for you to try and like put it in the right order, it gives it to you right here. Okay, in the right order. Okay, so you don't even have to worry about that. And then what's our reason for that, Eric?
All the sides are
Right. So side. Okay. All right. So flip your paper over. Flip your paper over. We're going to try another one here. You don't have it back to yours. What? Oh, okay. It might be because of the notes. Yes.
I have one.
Oh, you do have one? Okay. Thank you. Yeah, there should be an original one. Okay. So you'll notice something's missing over here. There's no statement and reason table. So we're going to have to make our own little chart here. Okay, so statement and reason. At the top there, reasons. Okay, so let's pass one. Sorry. Thank you. Okay. All right. So let's start here. So the given information is that triangle PST is equilateral. Okay, what does it mean for a triangle to be equilateral? All the sides, right, are equal. Okay? So all the sides of this big triangle PST, all the sides of this are equal. Okay? Also, we're told that E is the midpoint of segment TS. So E is the midpoint of segment TS. So here's segment TS, E is in the middle. Okay? And so then we want to prove that these two triangles are congruent. PET, so this smaller triangle, we want to prove it congruent to the big triangle here, PES. So you need to come up with 3 congruences. Okay? So, what can we mark congruent here? Ideas. Yeah, Eli? PT must equal PS. Okay, where'd you get that from? Okay, yeah, so this piece of information comes from the fact that triangle PST is equilateral. So a triangle PST, the big triangle here, and I know it doesn't look that way, right? PS definitely looks shorter than ST does, but we're going to, use that fact anyway. It's just not drawn very well, that's all. Okay, but yes, PS is congruent to TP, so we're going to go ahead and say that. Okay, and again, we knew that was true because triangle PST is equilateral. That means all the sides are equal. Okay? So that's our reasoning. All right. So we've kind of used that piece of information to get a congruence there. So we kind of checked that piece off. We used it to get a piece of a congruence. All right. What else can we say is congruent here? Someone else besides Eli. What else can we say is congruent? So Debbie, what do you say?
Line TE is congruent to FE.
Okay, so segment TE, so I'm going to use double tick marks here. It's a different kind of thing. And then ES, or SE, segment SE. So yes, segment TE is congruent to segment ES. Right, and that's because E is the midpoint. So E being the midpoint, it cuts that big segment into two smaller but equal segments. So our reason is E is the midpoint. Okay. Questions on that? BJ, Kwanya, Eli. Listen up, please. I'm going over this stuff. Don't be talking. Okay. Notes is more than just writing stuff down, right? You should be thinking about it as well while you're writing it. If you're having a conversation and all you're doing is just copying down what I'm writing up here, that's not helping you at all, okay? It's useless. You need to be listening and kind of thinking along with me here too, okay? Ask yourselves questions. Why do I put that down? Why does that go there, kind of thing. And if you're unsure about something, that's when you ask me. So yeah, Corey?
So you put PST is equilateral. What did you put instead of putting TP? What did you put PS and PT?
Yep, that's fine. PS and PT, that's fine as well. Yep. Still the same segment. Okay, we need one more congruence here. One more congruence. What else can we say is congruent in this triangle? Let's go. Alex, you have an idea?
Wouldn't PSE be congruent to PT?
Okay, so the angle there?
Yeah.
So technically, yes, we could say that. Okay, what would be your reasoning for that?
Because, like,
They look like it should be, right? Okay, so, and actually we could argue that here, okay? But the argument can't just be because they look the same. But, yeah, Corey, what do you want to say? Okay, so yes, we could say that, so I'll go ahead and write that one down. So, PE is congruent to PE. That's an easier one, I think, to see here, because, what's the reason there, Corey? Reflexive property. All right, but I want to come back to Alex's point in just a second here. We'll finish this one out, because this is the way I was normally going to have you guys do it. But Alex is not wrong, and I want to hit that again. I want to come back to that. Okay, so again, yeah, PE is congruent to PE, so I'll use the 3 there. Okay. And so our final step here, let's go to, so Piper, what's our final step then to say? Yep, triangle PET is congruent to triangle PES, okay? And it's because we have 1, 2, 3 pairs of sides, so it's side, side, side. Okay. Okay. Now, I want to go back to what Alex said because he was not wrong there, but we need to come up with a good reason for it.
well, when it says consider a parallel that
Kind of like that, yes. So again, what kind of triangle is triangle PST, the big one? It's equilateral, okay? If all 3 sides of the triangle are equal, guess what else is equal? The angles are all equal as well. And so angle S and angle T are both angles of this big triangle, and so they'll be equal because all their sides are equal too. So you could actually get away with saying, you know, triangle PSE, or sorry, angle PSE and PCE are congruent because this triangle is equilateral. You could use the same argument as you did there. So that would work, and then it would be side, angle side for yours, which is that's a legitimate congruence proof too. So that's another way to do it. All right. Let's try another one here. Last one, and then we'll move on to today's proofs. We're going to use different ones today. Okay. Okay. So let's see here. Let's go to. Oh, she's not here. All right. So. Oh, we already heard from some of these people. Come on. Okay, there we go. All right. So we'll start out again. Writing our little table there. Statements on the left side, reasons for those statements on the right side. All right. And we'll read through our kind of given information here. So ray, right, because I got a little arrow up there, ray MR bisects angle KMA, and MK is congruent to MA. All right, so I'm just going to focus in again on our picture here first, and then we'll worry about trying to write our statements and reasons down. So God bless you. So Josh, can you give me a congruence? Can I mark anything congruent based on the information that we're given here? There's two pieces of information. Can I use either of those two pieces of information to get a congruence here? Josh, what do you say? Can I mark something congruent in my picture here based on one of these pieces of information? So no, you do. You do actually. You're giving up too quick. So you look here, you have one piece of information, ray MR bisects angle KMA, and then I have a second piece of information, segment MK is congruent to segment MA. From either of these pieces, can I mark something congruent down here? What's the congruence we're given? Just look at the information here. Which one of these gives me a congruence? Says something is congruent. MK is congruent to what? MA. So down here in the picture, I'm going to locate MK. Right here, there's MK, right? So we'll mark that congruent. And was MK congruent to? MA, yeah, see, just like that. That's it. Okay? That's all I got to do for that one. All right, Jason, how about you, sir? Can we mark something congruent based on the fact that ray MR bisects angle KMA? So here's KMA, it's kind of the big angle right here, and MR bisects that. So what does that mean? Okay, so careful, it's not sides that are going to be equal. MR is bisecting an angle KMA. So what two angles are going to be congruent based off that? Close. It's not MKR. It's not this angle. We're bisecting the big one right here. So it'll be KMR, this angle right here. Okay, we're going to mark that with our little arc there. Okay, Corey, question?
KMR parallel to MRA because KMA is called
Bisector?
Yeah.
Okay, so close. You said KMR, but then you said MRA. So you're talking. So be careful how you name it. It should be not MRA. It should be what? AMR. Perfect. Yes, that. Okay, like that. Very good. Yes. Okay. Yes. Those two angles are congruent. Okay. Good. So Jason, you see what we're talking about there now? All right. All right. And there's one more congruence we need. I see 2 congruences. We need one more congruence here. So let's see. Blake, can you give me one more congruence that you see just based on the picture there? MR is congruent to? MR. There you go. Great job. Good look. Okay. So let's write those 3 congruences down. Okay. MK was congruent to MA. That's what Josh told us, remember. So we'll write that here. Okay. And Josh, what would our reason be for knowing that? How do we know that was true? How do you know it's true? How do we know that this statement was true? Where do we get it from? It's in the given information, okay? It's given information, Josh. That one's an easy one because it's right there in the given, okay? It was in the given information, okay? Do you understand that? Yes, no? Okay, so again, whenever we state something is congruent, we need a reason for it. The reason here is just out of the blue given to us. It's in the given information, so the reason that we know it's true is it's given to us. It was just someone gave it to us. Whoever wrote this problem gave that piece of information to us. So it's just given. That's our reason we know it. Okay. Step 2. Okay, we just said then that angle KMR, Jason and Corey both kind of answered this one, is going to be congruent to angle AMR. Okay? And Corey, what was the reason we knew that one was true?
KMA is,
Look in your given.
oh, the MR bisects.
Exactly. MR bisects angle KMA. Anytime we see a bisector or a midpoint, we know that's going to create two equal things. Okay, an angle bisector creates two equal angles. A midpoint creates two equal segments. All right? And then, Blake, how did you know that MR was congruent to MR? What's the reason for that? The reflexive property. There you go. Great job. Okay, so segment MR is congruent to segment MR by the reflexive property. Okay? And so the last step here then is to show these two to say these two triangles are congruent. So we'll say triangle KMR is congruent to triangle AMR. Okay? And so which triangle congruence shortcut are we talking about here though? Addie, what do you say? Is this side, side, side? Side, angle, side. You got it. Exactly right. We have a side and the angle and then a side congruent to a side, an angle, and a side. You see the angles between the two congruent sides there. So it's side, angle, side. Good job. All right. Questions on any of that? Yeah. Okay. All right. So while you guys finish that up, if you have any questions, let me know. Otherwise, we're going to look at some more proofs today. We're going to look at angle, side angle, and angle, angle, side today. This is day 2. Yes. Josh, here you go, sir. Make sure you're following along, Josh. You want to write those down. Don't just sit there with your elbow half up your arm, okay? Okay, number next. Number next? Next number? Number next. Okay. So let's look here at what we've got. And actually, I kind of want to, let me see. Okay, yeah, I'm going to be fine with that. All right. So let's take a look here. We'll do these 3, and then I'll give you guys time to get started on your assignment here tonight. Okay. So today we're going to focus on angle, side, angle, and angle, angle, side. All right. So those are going to be our 2 big ones there. We're not going to see any side, side, sides today. We're not going to see any side, angle, sides today. So you can not forget about them, but put those in the back burner for right now. We're going to focus on these. Okay. So when we go to finish proving it, we're looking for either 2 angles and a side between them, or 2 angles and a side next to them. Okay, so we'll kind of see what that looks like here in a second. All right, so let's kind of tackle the proof in the same way we normally do, though. We have some given information here. You'll notice here some given information. We have some congruent angles, right? Not congruent sides, but congruent angles. And then we're trying to prove, okay, that triangle HIJ is congruent to triangle JKH here. So let's mark some things congruent, right? So JHI, so you need to be able to identify where is JHI. Well, if you look here, here's JHI, JHI, JHI. So it's this angle right here. Okay, so we'll mark that congruent. to HJK. Now you have to forgive me here, the copier kind of like lost the K. There's where the K is. So HJK, 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 HJK. It's this angle right here. Right? All right, the next angle, IJH. So IJH, IJH, IJH. So it's this angle right here. We're going to use two arcs there like that, because it's a different congruence. And then angle JHK, 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 JHK. Okay, like so. Okay? Now, we have one pair, two pairs of congruent pieces of our triangle, and we've used up our given information. Is there anything else, just by looking at the picture of the triangle, we can say is congruent here? Go ahead, Eli. You said HK will be congruent to KJ?
No, HI.
Oh, HI is congruent to KJ. Okay, why would you? What's the reasoning for that? Yeah, so, and again, you will be right, but we need to have a good reason for it. And I think you missed an easier congruence here. There's actually an easier congruence C. Yeah, JH is, or HJ or JH is congruent to itself. So there it is, right there, for the two triangles, okay? So we've got one pair, two pair, three pairs of congruent pieces of information, so we know we're done with this proof. We just have to write things out now, okay? So congruence 1. Well, we have it in the given right there. Angle JHI is congruent to angle HJK. And again, the reason we know that's true is, anybody? Given. Okay. Step 2. So we've used that congruence there. Angle IJH is congruent to angle JHK. Okay. And again, Josh, what would our reason be here? We said angle IJH is congruent to angle JHK. How did I know that was true? Given. Yeah, it was given information. Good. And then step 3. Okay. This is what Eli pointed out, right? We'll say that segment H to J is congruent to segment H to J. Okay. Just like so. And the reason for that is what, Colin? W. What's the reason for that? Well, we're not told it doesn't quite bisect, right? Because there you go, reflexive property. That's right. There you go. Something congruent to itself is the reflexive property. Very good. And again, I'm just going to abbreviate that, reflexive prop. Okay. Thank you, Colin W. All right, so column S then. What are the two? Name the two triangles here. Triangle what is congruent to triangle what? It's in what we're trying to prove. So triangle what? HIJ is congruent to what? JKH. Okay. Now, column S, which is it? Do we have angle, side, angle? So do we have two congruent angles and then the side between those two congruent angles congruent? Or is it angle, angle, side? We have two congruent angles and it's a side next, like kind of on the outside, not between the two angles congruent. Which one is it here? Yes, it is. Good job. Angle, side, angle. The congruent side here is between the pairs of congruent angles. Okay, so it's angle, side, angle. Very good. Nicely done. Okay. Cool, cool, cool. All right. Questions on that one? All right, ready to scoot it up then? Let's scoot it up. All right, number 2, and like I said, we're going to do these two here, these last two, and then we'll give you guys your assignment here for the day. So, all right, let's keep moving here. So in this one, we're given that angle B is congruent to angle C, angle D is congruent to angle F, and M is the midpoint of DF. So I'll go ahead and mark these congruences in. They're easy. B and C are congruent, so B and C, those are congruent. And then D and F, they're congruent. And then, so that takes care of those two congruences. And we need to come up with another congruence. Can I say that these two angles are congruent right here because they're vertical?
No.
Yeah, are they vertical angles? Not quite, right? So, like, these two sides are opposite each other, but these two sides are not. If I jump down here real quick, I see your hand, right? Just 1 second. If I look down here, are these two angles vertical angles? Yes. So I would be able to say they're congruent in the next proof. But these two are not, because they're not vertical. They're not exactly opposite each other. They look like they're going to be equal, but we can't say for sure yet. So let's go to W, okay, and then I'll...
I have a question.
Oh, question.
What's the difference between ASA and AAS?
So the difference there, and you'll notice, is the position of the side. Here, the side was between the two congruent angles, and then for AAS, which we're about to see here, it'll not be between them. It'll be like next to them in order kind of thing. You'll see it. So Eli, you want to say something?
Oh, yeah, we could say that DM is equal to FM.
FM, yeah. DM is congruent to FM, or MF, MD, DM. You can switch those letters around, okay? And then you get, yes, DM and FM are congruent there. So we have three congruences, right? 1, 2, 3. So let's list those out. So we already have angle B is congruent to angle C. That's given. Okay. Angle D is congruent to angle F. That's given. And then DM is congruent to FM. Okay. And what was the reason for that? What piece of information do we use to say this was congruent?
The midpoint.
M is the midpoint of DF. Exactly right. Okay. So I'm just going to let you guys know. If you're given a piece of information other than a congruence, so here we're given two congruent pieces of information, and this other given piece of information, you're going to use that as a reason for another congruence, basically. Okay? All right.
And this will what?
M is the midpoint of segment DF. Okay, I know my handwriting's not that great. All right, so let's see here. So then, what two triangles are congruent here? Let's go to, let's see, who have I here? Mitch, go ahead, Mitch. What two triangles are congruent here, then? Name them for me, please.
ABC, CDA.
Okay, now you know what? This is really weird.
They're not labeled right.
Yeah, they're not labeled right, so we can't use that one, okay? I need to fix that. All right, so we have to name them old school here. So go ahead, name this triangle there, Mitchell.
BDM.
All right, triangle BDM is congruent to,
CFM.
very good, triangle CFM, very good ordering there. And then which congruence is it? Is it angle, angle, side, or is it angle, side, angle? Do you agree? Angle, angle, side? Yes, it is angle, angle, side. W, do you see why this is angle, angle, side? And so folks, for those of you maybe don't, it's angle, angle, side because it goes angle, angle, and then the side. Or I also would accept side, angle, angle if you want to, write it the other direction there. Side, then angle, okay? It's the side here is not between the two congruent angles. If CF were congruent to DB, then it would be angle, side, angle. But with the way it's written, that's just angle, angle, side. Okay? Questions on that one? We've got one more to go. You guys are doing great. All right, we're going to keep it up here and finish this one off. And I saved the best one for last. Okay? I like this one a lot because it brings back some information that we learned way back in Unit 1. Or that So let's take a look here. All right, so the first piece of information we're given here is that AD is, what is the symbol? Parallel to EC. So AD, I'm going to mark that parallel to EC. Does that mean that AD and CE are congruent, though? No, just because they're parallel doesn't mean they're necessarily congruent. We can't really pull a congruence out of that yet. We can't say the side's congruent. So I'm going to say that again because some people maybe aren't paying attention, and I'm going to see this later, and I want to see this later, okay? AD is parallel to EC, That does not mean those two sides are congruent. Okay, just because they're parallel does not mean they have to be congruent. We will come up with a congruence, but it's not going to be that AD is parallel or congruent to CE. They are parallel, but they're not congruent necessarily. Okay, BD is congruent to BC. Okay, so we know this is congruent to that. And we want to show the triangle ABD is congruent to triangle EBC. So these two triangles there. All right, so right now, how many congruences do I have marked on my triangle?
3.
I have one marked in my triangle. I have one marked in my triangle. DB is congruent to BC. One pair of congruent pieces. Okay? We don't know that AB and BE are congruent. We don't have enough information there to say that. What else could we maybe say is congruent here based on the picture that we said earlier, Kwanye? Oh, you're... Yes, CBE, that angle will be congruent to ABD, and again, why is that? Not because it's a midpoint. What's the reason? What's that? Nope, not quite. Go ahead, Eli. Vertical angles. They're vertical. They're opposite each other, so they're vertical angles. They're directly opposite each other, so they're vertical. Okay, here you can, right? These are vertical angles. They're opposite each other. Okay, I know, right? You can see like the germ on the tip of my pen there. Okay.
Oh, so when that makes DBE?
Yeah, angle DBE and ABC would be congruent, but those aren't angles of our triangles, so we don't want to necessarily say. But yes, they will be. They will be, absolutely. All right, now, here comes the review from Unit 1. When we have parallel lines crossed by a transversal, right? Or we can talk about these parallel lines crossed by this transversal, right? Don't we create alternate interior, alternate exterior, corresponding, and co-interior angles? Okay, so we know that if these lines are parallel and we have a transversal, alternate interior, alternate exterior, corresponding angles, they're congruent. So can we say something is congruent here based on those pairings? Okay, Debbie, what do you say? Yes, so we could say angle C is congruent to angle D, or Eli, what's another option that we could say here? Oh, okay. Well, so think about angles. Angles will be congruent here because of those parallel lines. So C and D would be congruent, but what other pair of angles could be congruent too? Could we mark congruent? E and A. Yeah. And so it's up to you guys to choose which one you want to mark congruent there because both would work. Did you have something else you wanted to say there, Eli?
I was going to say CBA is congruent to DBE.
That's correct. The only problem with that is this angle here is not part of any triangle. You see what I'm saying? Like these two angles are important because they're part of these triangles. But then these two angles, they are going to be congruent, but they're not part of any triangle. So it's true information, but it's not going to be helpful towards what we're trying to do, which is prove those two triangles congruent. So all right, let's go with what Debbie said earlier here. We'll mark these two congruent. Okay, and so now let's go ahead and start naming things here. So BD is congruent to BC. And again, the reason for that is given information. Okay. And then Kwanye said angle ABD is congruent to angle CBE. Okay. And Courtney, do you remember why we said those two angles were congruent? These two, because they're what kind of angles? Vertical angles, yep. So vertical angles are congruent. Wow, I actually wrote the word congruent out this time. I don't know why. You can use the symbol for congruent there if you want to. Sorry, I know I'm not showing it there.
Can't see the right side.
Yeah, I'm sorry, Tristan. I moved it now so you can see it. Thank you for saying something. Okay. Ugh, it's a mess too. Okay, there we go. And then lastly, we can now name, for example, angle D and angle C. Notice here it's okay to use the single letter angle name because there's only one angle at those two vertices. If I just said angle B here, well, there's a lot of angles at angle B that I could pick from. But if I just say angle D and angle C, that's okay. Okay, now, Debbie, you said that D and C were going to be congruent, but why? What special angle pair are they? Alternate interior angles, yes. So we have to say alternate interior angles okay, are congruent. Since we have those parallel lines there, alternate interior angles are congruent. So remember that from Unit 1, our first unit, that's what we talked about. Okay, those parallel lines. Okay, we have three congruences, so we're ready to prove this triangle congruent. So triangle ABD is congruent to triangle EBC. Okay? And so what congruence is this, though? What congruence is this? I'm going to go to Curtis here. All right? When you're done writing there, Curtis. What congruence is this? Okay? Is it angle, side, angle, or is it angle, angle, side? Look at the order of the information there. Is that an angle, then a side, then an angle? Or is it angle, then an angle, then a side?
Angle, side, angle.
Angle, side, angle. You got it. Thank you, Robbie. Yep. And so these triangles are congruent by angle, side, angle. Great job there. Okay. All right, one more thing here, and then I'll cut you guys loose on the homework, okay? So, remember that we could have also said that E was congruent to angle A here. What else would have changed in our proof? If I had, instead of saying C was congruent to D, if instead I did E congruent to A. Okay, so let me maybe redraw that here real quick so you can see what I'm talking about. So, okay, so for example, let's say I had something very similar. Okay, so what we have up there, so we had this part was congruent, we had this part congruent, but instead of marking these two pieces, so we had these two pieces, and Curtis correctly identified that was angle, side, angle, angle, side, angle. What if instead we went with the other angles and said they were congruent? What does that change about our proof now? Go ahead, Eli. Yeah, exactly right. Gabe and Eli and anyone else, that's right. Now it becomes angle, angle, side. Okay? So sometimes you have your choice depending on about how you go. You know, one person might do it the first way we did it here and end up with angle, side, angle. Another person here might end up with angle, angle, side. Okay? So either way, though, is correct. You can go, in this case, you can go either way. Okay? All right, flip your paper over, and I want you guys to try these three proofs here. Okay? Let me see here. Maybe I won't have to do three. Let me see. Yep. Yeah, I'm going to have you do both. All three, I mean. So yep, try all three proofs there. Okay? So that's going to be your assignment for tonight, is do all three. You'll need to make your own little table.